Hi, Joe Cerrone.
And Alan Rosen.
Welcome to CAD 107, Introduction to 3D Printing, and our Zoom classroom meeting. Okay, so we're in D2L and we have our agenda. And so you can download the agenda. Today, we're going to review our work in progress and our projects. And so if we click on this link, we can see our file. And actually, this is the PowerPoint one. Let's get the other one. And so we're going to review our projects. And so we're looking at why would use a 3D printer and 3D printable materials from our textbook. And the textbooks that we're using are this Mastering 3D Printing and 3D Printing Projects. So as we go through and we work with these projects, the theory will come through the Mastering 3D Printing, and then the projects will come through our 3D printing projects. The software we're using is AutoCAD. And so the course is primarily taught with AutoCAD. You can use a different software, but AutoCAD is our primary software. And then we'll be using the slicer. And so you need to download the Dremel Digi Slicer as well. So you will need two softwares. And so you'll need your CAD. And so here's my CAD system. And then the way that the projects work is that we create these different projects and we model them according to the instructions that we have in the videos. And then we export them into the slicer. And so I can say export. And then I can export this as an STL file. And when I export that, what I'll do is I'll select the object and hit enter. And then that will export it as an STL file. And then I can go into my slicing software. And let's clear this one off. And so this is our Dremel slicing software. And you can download that from the Dremel site that's in our PDF. And then what I can do is I can open up those files for slicing, for printing. And so what I'll do, just get my screen over here. Is I can take the file, bring it into the slicer, and I can slice it. And so I have it set up as PLA using my Dremel materials. And it's polylactic acid. And then we can set up the different quality levels. I have it set up at 0.3 millimeters, which is low quality, and I'll demonstrate that. And so as we work with our slicing software, we're just going to go through some of the basic aspects of it. And one of the basic aspects is build plate adhesion. And so we're going to set this up so that it has a brim on it. And then when I prepare it, what you're going to see is how that project is held to the build plate. And so this is what's called a brim. And if we hit the eye here, we can then go through and we can see how the part is sliced. And so from a review from the beginning, if we were to take this out and just delete it, I'm going to open up my STL file and I'm just going to drag and drop it in. And so I can just drag it onto the build plate. And if it doesn't go on the build plate, then you just need to use these tools here to locate it. And so this is our move. And so we can move it onto the build plate. And then once it fits on the build plate, and I'm pushing the wheel on the mouse, I can increase the magnification. Then what I can do is I can slice it. And so I set up for the quality that I want, and I'm going to set it up at 0.3 millimeters. And I'm setting it up for a brim. And then when we prepare it, we can then see the layers. And so this is what we do when we receive your STL files. We go through and we slice them, we give you a print screen, and then we can see that it's going to take 1 hour and 7 minutes. Then what we do is we print the project, and I'll show you that on the next one. We're going to switch to a different camera. And this is going to be our HD Pro camera. I'm going to stop my share. All right, how does that look, Al? No? How about now? Great. Okay, so as we look at our project, here we have 2 of the projects that have been printed. Okay, and you can see that we have this build plate adhesion on it. Okay, and this needs to be removed. And so we'll remove that with either pliers, and you can pull that off, or you can use a clipper to clip that. And what we will do is we will take your projects, and once you have them printed, we'll have them available for you to pick up. But essentially, this is what they look like when they're done. We can do some post-processing to them, but you can use whatever text you want, provided that it's within the standard academic codes of conduct. And then what we're going to do is we're going to print these, and you'll be able to pick those up. Alrighty, so back to our PowerPoint. So we take them and we export them from CAD, bring them into the slicer, and then like you can see on our coaster project, we then take those into the slicer so we can learn how to work with different things like selecting the material and the quality level. If I were to go back to the Dremel slicer and change the quality from 0.3 millimeters to 0.1 millimeter, ultra high quality, I'm going to keep my generate support and build plate. Now, I do not need build support for this, and we'll talk about that when we look at the next project. But as I go through and prepare it, what you're going to see is that at a higher quality, my print time is increased 3-fold. And so as we work with the quality levels, there's kind of a balance between how the part looks and the quality level and the time that it takes to do that. Alrighty, back to our PowerPoint. Oakton 3D printers, we're going to be using these Dremel 3D 45 printers. And the Dremel 3D 45 printers came out 5 years ago. We're looking at possibly upgrading them to their newer printers. And we have these different components to the printers. And so as we look at our printer, we're going to switch over to our other webcam. How's that? So here's an example of one of the projects that we recently printed. We have our filament located right here. And this is our PLA, and it comes in on a spool and goes into our extruder up here at the top. And this is our pallet. And our pallet basically bolts into the screen, into the machine down here. I'll take that out in a minute. And then it's controlled here by this interface right here. And so when we build, what we'll do is we'll put a USB into the machine and read the G-code file. We can go through and we can load the filament and change the filament, and we can level the machine, and we can show you those aspects as we continue on. But for right now, I just want to review the projects. And so we'll print your projects after you've made them into an STL. They'll come out on this pallet. And then what we can do is we can take them off the build plate. Now, these didn't have any problem with build plate adhesion. In fact, they came off pretty easy. What we do is we put glue onto the pallet, and then we put the parts, and then it's extruded onto the build plate. And so here's an example of what the projects will look like once we're done. Now, I did not put a brim or any build plate adhesion on this, and this one worked pretty good. Sometimes what will happen is the parts will kind of lift off or have some difficulty. And so as we're working with designing for 3D printing, we're looking at how the parts are adhered to the build plate, and we're using basic extrusion techniques for 3D modeling. And so the project 2 was to create these different coasters, which we'll be able to create and stack up. They're going to be dimensionally accurate. And then we're going to print those with PLA for our second project. So continuing on, so as we look at these 3D printers, they have a full enclosure, which is good because people, if you have small kids in the house, or if there's a possibility on somebody opening this and putting their hand in, there's not a lot of danger involved with 3D printers, but it does get hot. And if you're building something that takes 6-8 hours, then having somebody open it up and pause the printing or something can cause a problem with the door. It has an RFID, radio frequency ID, so it automatically identifies the material. And so the Dremel printers will know what type of material it is based on the sensor. It can print 10 inches by 6 by 6. And this is a little ambitious. It's really about a ½ inch shorter on each of the axes. You can remove the build plate. And then we have this touch screen that's used to be able to program it. It's one of the best in class, 100 micron build. And then it's got these leveling sensors and Wi-Fi and Ethernet. And so it's really pretty nice. You can have Wi-Fi enabled printing, and it also has webcam built into it so you can monitor the webcam. We're using additive manufacturing, or FDM, fused deposit modeling. And this is straight from our textbook, where the filament comes in off of the coil, goes into the extruder, and then the extruder is heated up, and then it is put onto the pallet, or our heated pallet. And here's when we use a 3D printer. We're using it for a design like this, which we can use basic 3D printing design type work. Some of the other types of prototyping equipment would be like CNC machines, which would remove the material. But as far as our projects go, what we're doing in our second project here is we download the files and we can then extrude them. And so here's an example of the student file. And so here's my student file. And then the project is to use the press pull command. And so we say press pull, and then we can press pull this object into a 3-dimensional shape. And I think we're making these 5 millimeters. Shift middle mouse wheel, and I can orbit that. And then again, we export them and bring them into the slicer. And so we can export it and bring it into the slicer. You think I should do that again, Al? Or should we go on to the next part? Okay, we'll keep moving that along. And so again, we export it, bring it into the slicer, and then we can work with that. And I can show that real quick because I think I have it. Okay, I'll keep it moving along. All right, back to the PowerPoint. So the file types are important. As we're working with these different file types, we're using these drawing files, and we're using those within the 3D printer, and we create these STL files for the slicer. The book talks about prototyping, 3D printing, laser cutting, and CNC machines. And so the theory behind it is when to use which machine. For our purposes, we're just looking at 3D printing at this time. They're slow, they use filament, and we can then basically create these parts using our CAD system. Some of the projects that we'll create, we're showing here in our 3D printing projects. Here's our first project. Our learning objectives are to design and print our door. And then here's our second project, which we've demonstrated. And then our next project will be to create a design of our own and then to model the coaster holder. And so again, we're going to go through and create a geometry, but this time, instead of downloading it, we're going to create the shapes according to the sizes given within the lab from the textbook 20 3D printing projects. And so we'll make this 90 millimeter by 90 millimeter custom designed coaster. And so here's an example of our last project. And it's the same techniques where we go through, we model it on AutoCAD, and then we can use press pull to design for 3D printing. And so when we use press pull, we can grab the geometry, we can pull that up, and you can see this is why we want things connected, because I'll have to press pull more than one element. So if I press pull that up 5, and then I can come in here and press pull this one. So we want these boundary shapes that we'll use then to be able to create our projects. And this is what we mean by designing for 3D printing. It seems fairly simple at this point, but from a standpoint of being able to create these different shapes and geometries, this is how we will create our geometry. And you will turn in the drawing file as well as the STL. And then we'll create the holder for it as well. All righty, back to our PowerPoint. And that's where we're at. That's a review of our projects. As we continue to work on our projects, we'll manage the course through D2L. And then as we take a look at the projects, project number 1 is currently available. Project 1 is to print the do not disturb sign. Project 2 is to produce the 4 coaster models using press, pull, or extrude. And then we're going to turn in the CAD file along with the STL file, and we'll print those for you. And then project 3 we're releasing today is a project which we will model our own coaster. And we'll also model the holder for it. All righty. Back to the main splash page. Remember, we're broadcasting on Wednesdays from the Skokie campus, where you can come in if you'd like to come in for a flex class where you can work while we're going through the projects. And we're here from 9 a.m. until 12 p.m. Al, is there anything else that we might want to talk about before I end this recording?
No, just a reminder that on the 25th coming up, there's no classes until 5 o'clock.
So that's the learning day on October 25th.
That is correct, Joe.
All right. So we'll keep that in mind. And with that, I'm going to stop the recording and we'll open things up for questions.